Hello, how's everyone doing? All right, I'm Steve. Welcome to my presentation. This is Credential Protection in Passwordless Era. Today, it's a very brief presentation. It's only 20 minutes, so I'm going to hold questions until the end if there are any. But what we're going to look at is a brief overview, basically, of how we protect your credentials in Windows. Starting from, from almost the very beginning all the way into what we have in the passwordless era. So let's level set. First things first, how do people steal credentials? Well, very first thing is you got to start somewhere. You're running on a box at some point. You escalate up to an administrator and you start rooting around. At some point you find other interesting secrets, other passwords, other credentials, and you start stealing those and you use those to move to other devices. Once on other devices, you do the same thing. You start looking around. What other devices do you what other credentials do you have on there? And you repeat this process over and over and over again until you get some really, really interesting credentials. At most companies, you do this enough, you end up getting domain admin. That's probably not good. You get enterprise admin. You start with just a standard user, you move all the way up. It's not a good story. It's how quite a number of attacks out in the wild end up, completely destroying companies. And so I'm actually just going to show you really briefly how you do that. This is Riley, by the way. She's a 2-year-old dog. She's the cutest dog in the world. Has absolutely nothing to do with stealing credentials, but she's an adorable dog. So, you guys can see that? One of the common tools that people end up using, either as a demo or as a baseline for a lot of their attacks, is Mimikatz. The way that Mimikatz works is it attaches itself to our logon processes in Windows, and it roots around. It looks for passwords. It looks for things that are juicy, that are interesting. And so, if we run just a single command, get the logon passwords, it dumps a ton of stuff. And as we start digging through them, we can see some really, really interesting things. For instance, your NTLM hash for your domain password. That's not my corporate domain password, that's a demo password. If you happen to copy that, drop it into Bing or Google or anything like that, you'll actually find the password really easily. It's p@ssw0rd1. After some point, you just kind of start recognizing them. There's a bunch of other things. In some cases, as you scroll through the bunch of other corporate accounts, you start getting, that's your host computer account. Oh, by the way, hey, there's your host computer account password in the clear text. Not good. As soon as you start collecting these credentials, you start moving to other devices. You switch to, you ping the network, you search for other devices, you find, oh, I can connect to that. I'm going to go run software on that. And oh, hey, I know about this administrative privilege escalation. I'm going to elevate to admin, switch to that, and repeat the process over and over and over again. Some of the other things that you can do in a not-Windows environment, you can start stealing session credentials from websites. For instance, you're logging into your email or you're logging into your line of business applications on the web. You can do things like grab the session cookies out of the headers and use them on other machines. And as you do this over a period of time, you start collecting a mass of credentials. So, what do we do about that? In Windows, we have a collection of technologies that I affectionately refer to as the guards. In the beginning, we started with Kerberos and NTLM. These were the main protocols that you used in enterprise environments. They're ubiquitous. They've been around in Windows forever, basically. And they allow you to single sign-on into everything. And so over time, we start to protect these. And the first thing that we did was we used smart cards. We offloaded the authentication credentials onto physical hardware so that you couldn't steal things out of memory. There were no passwords to steal. You had a physical device that you plugged into your computer and you used that to log in. Problem with that is this thing called the Kerberos TGT. It's the ticket granting ticket. It lives in memory. You use your smart card or your password to talk to Active Directory, get a TGT, and use that TGT to start accessing other resources. For better or for worse, that TGT is stealable. So then we introduce the TPM. In this case, the TPM doesn't actually provide a lot of value at the Kerberos level because we could not modify the Kerberos protocol to have hardware support. So I'll come back to that. Then we introduced the Guard, the Credential Guard. Credential Guard uses virtualization-based security, which, if you're not familiar with it, is very simply, it's a virtual machine that you don't know about that's running on your machine. It's a very tiny virtual machine. It takes up very little resources. It's running a secure version of the Windows OS. It's tiny, absolutely tiny. You'll never know it's there. But what it does is it offloads all of the security functionality into this virtual machine. So when you're using Kerberos, when you're authenticating, when you're doing any of these things, any of the things that were originally stealable now belong in Credential Guard. And in actual fact, the way the Credential Guard works is it uses secrets from the TPM, rooted in the TPM specifically, and encrypts all of these secrets for you. So they still live in your side of Windows, in the user mode side of Windows, so that we can use them, but you can't decrypt them. You can't steal them. If you pick them up and you send them to another device, they're completely useless. Then we started getting into modern protocols. Modern protocols are things like Azure Active Directory, so Cloud Join. Or for the consumers, we have your Microsoft account authentication. In some of these cases, they're TPM bound, so that means that you can't take tokens off the device. And what that allows you is, if you take the token off the device, you require the TPM. TPM's not there on the other device, so you can't use it. There are some interesting side effects of that. The TPM is kind of slow. It's actually really, really slow. So when you're doing, when you're looking for fast authentication, it's a little problematic. In some cases, it takes a couple seconds to do anything under load. So we'll come back. We introduced Windows Hello, which is a way to change how you authenticate. We get rid of passwords and we switch to bioauthentication. So it's using things like facial recognition, or it's using thumbprints for your fingerprints, or it's using pins. Or what we actually recently came out with were security keys. You can use a FIDO2 security key. We call it the Windows Hello security key. You plug it in, you tap your finger, and you can log in. You can take this to any device you want. But the value is, with Windows Hello, because you're not using a password, you're using the security key that's bound to the TPM, so it's hardware bound again. It's not portable anymore, except if you have something like this, which is designed to be portable. So no more password. You log in with your face, you log in with your fingerprint. You have this way it's only tied to a specific device. Or if you have something like this, where we guarantee that you can't steal the credentials off the device. And then one last thing, which is KeyGuard. How many of you have heard of token binding? No? No? Oh, a couple people. Cool. OK. So token binding is the last step of our protection mechanisms that we have in place. And that actually doesn't help with authentication specifically. It actually helps you with session protection. So once I've logged into the computer, I'm starting to access applications. I'm accessing Exchange Online. I'm accessing SharePoint. I'm accessing not Dropbox. What's ours? OneDrive. That's the one. You're accessing these applications. The problem is, going back to that cookie, you're using a cookie. You're using a bearer token. You're using a thing that, if I hold on to this thing, I can do whatever I want as this user. I am effectively this user. Token binding, much like the things that we're doing with Azure AD, with the TPM binding and the Windows Hello binding, all these different things, we're binding that token or that cookie to that device. And the value is, as soon as I steal that, I can't pick it up, I can't move it, it's totally useless. Now, you take these last few things, you put them all together, we have this really cool feature called Cloud Credential Guard. There's a moratorium on calling things guards now. Windows Defender, something guard, we're going to stop doing that, I promise, just because everyone seems to like the guard name. And the value with this is, it's completely transparent to the user. No one ever sees it going on. It's actually been going on for the last 4 years. If you've been using Windows Hello with Azure Active Directory, if you've been using Windows Hello with Active Directory, all of these pieces have been in place for Cloud Credential Guard, and it's just been working. You know, Over the last few months, we've been moving to newer versions of things. We're iterating. We're actually moving to the latest version of the token binding. It was token binding spec was finally ratified. So let's see some of this in action. So this is Bruce. Also has nothing to do with stealing credentials or protecting credentials, but he's also one of the cutest dogs in the world. So coming back to the demo machine. So in the last demo, I very quickly showed you this is how you can steal credentials with a tool called Mimikatz. One of the things that we have, which I showed very briefly, was Credential Guard. Credential Guard is intended to protect Kerberos secrets, amongst other things. But I have it running on this machine, on this VM. And so if I run that exact same command, what you will end up seeing is a lot of random garbage. Now, it kind of looks the same because it's dumping a whole bunch of stuff really quickly, but if I jump to the top real quick, you're not seeing the same data. You're not seeing those hashes unprotected. What you're actually seeing is encrypted values. So whenever you're needing to talk to Active Directory, basically what happens is our Kerberos system calls into Credential Guard. Credential Guard then connects out, decrypts the key, connects to Active Directory, gets the token, brings it back, uses Credential Guard to re-encrypt it, and there you go. You have an encrypted value again. So an attacker cannot actually take these keys, or cannot take these secrets and use them elsewhere. Some of the other things that we also happen to do as part of our constant ongoing process is we just start removing stuff out of our security processes entirely. There's a lot of data that we've just removed. You don't end up seeing, so for instance, we just have everything's encrypted or it's just not present anymore. You still, in some cases, get a couple hashes, but we've designed it in such a way that the hashes that you can actually get to are completely useless. You can't take them off, while you can access them, you can't take them off box and do anything interesting with them. In some cases, you also get encrypted, so that was the host account. It's the encrypted password. You can't steal that. You can't decrypt it. There's nothing accessible to you. A couple other things, token binding. So this, of course, locked my account. I built this demo special for you. It's a tiny little test app. If you want to go try it out, you can, ignite-tb.identityintervention.com. The way that token binding works is there's an agreement between your machine and the site you're connecting to over TLS or SSL, whatever you want to refer it to as. And what happens is when I've connected to a particular domain, your browser basically says, oh, okay, I'm going to guarantee that whenever I connect to this domain, I'm going to use a special key. And I'm going to make sure that whenever someone asks for this key within this site, I can prove that I own this key. Now, if you think about it, the value of this is that if I have this site give me a session cookie and I've bound it to this value, and I try and take it to another machine, and the site says, hey, I need you to prove you have that key, it can't, because it doesn't have that key. So if we imagine for a moment that I'm logging in, I get this weird session value. This is just demo. This is a demo for the sake of a demo. But the idea is that my username is bound to this key. And so if I copy this, and I open a new tab, and I go back and load this up again, what happens is, and I drop this in, this is like how you would do a session cookie. You end up seeing this value. Hey, yes, I'm logged in. It's the same session. You're good. There's no problems there. Now, let's use the right keyboard combination. Open up an in-private view. One of the things the browsers decided that is if you're using in-private view, we shouldn't actually be able to tie you back to a regular session. So if I pull this up again, and I drop this into the session, suddenly it doesn't have anything to bind it against, and suddenly I can't use that token anywhere else. So if you take that off box, you're completely hosed. You can't do anything about it. All right. So that's my presentation. Very whirlwind tour of all the different technologies. Any questions? A lot of confused faces. No? Yes?
So Credential Guard on top of the local business.
Yes.
What are the benefits? What are the...
Sure. So the question is, what are the benefits of using Windows Hello for Business with Credential Guard? I very briefly talked about what Windows Hello for Business is. It's bio authentication of users using your device. So when you're using Credential Guard is there to protect your Kerberos tickets. So when you're doing Active Directory authentication, it's used to protect the Kerberos TGTs. When you're using Windows Hello for Business and you're still connecting to on-prem resources, you still have to use Active Directory. You're still going to end up getting that TGT. So the value of those two together is that you're protecting your TGT and you're still using Windows Hello. So they go together quite well. Any other questions? Yes. Yes. Sorry, say that again?
So when you do it in mind, when you look at the pack section,
yes.
to get the recruitment,
Yes.
just see one inside.
Oh yeah, so I think, are you doing Azure Active Directory join in that case? Yeah, so in that case, we don't grab the group membership tickets. Yeah. Sorry, the group membership SIDs.
So why do you get TGS? Normally people take the pack from TGT.
No, so what you're actually seeing, so when you're doing Who Am I, that's actually showing you what are the group SIDs for that machine. So when you actually exchange it, so you're not seeing the entire pack. Yeah, so you're only seeing a subset of it. So the whole pack does include all of the tickets. Or sorry, all of the SIDs. Questions? Yes?
So if you're using, so they were showing like the FIDO authentication across RDP.
Yes.
If I were having people using user workstation, like on a knowledge worker workstation, if I'm using FIDO password on the RDP session, do I never expose the credentials to the user desktop?
No, you never do. So the question is, if you're using FIDO with remote desktop to a remote machine, are you exposing any of the credentials to the remote machine?
To the local machine.
To the local machine.
My question is thinking about ESAE type environments. Can I bypass, like can I reduce the credential exposure of the admin credential using?
Oh, I see. Yes. So in that, is the credential exposed to the local machine? In any case, even if it's not remote desktop, you're still not exposing that credential to the local machine, because you're using the FIDO hardware key. That key never leaves the device. So, for instance, using one of these, this is a FIDO2 biometric security key. The key itself lives on this device, so that's how it's portable, how I can plug it into multiple computers and log in.
So it doesn't need, so what I'm thinking is if I have people logging in with a local user, but they're plugging in their admin FIDO key.
Yes. Yeah, that works.
That's fun.
Yes. Isn't it great? How many of you had a chance to look at the FIDO keys? A few people? Yeah. So the value of the security key is that with normal Windows Hello, your credentials are bound to the particular device. So if you ever have to move to a different computer, you have to re-enroll on that device. That can be problematic in certain scenarios. So if you have this Windows Hello security key, the credential is tied to this instead of the device. And the value is you can start moving to different PCs at any time without having to re-enroll. Yes? Sorry? You would revoke it at the server. So the way that this works is there's a private key on this device. There's a public key attached to the authority, which in this case is Azure Active Directory. You just remove it from Azure Active Directory, and it can't authenticate anymore. Yes? Yes. Yes. I'll talk about it. So the question is, paraphrased, just this week at Blue Hat, at our Microsoft Security Conference, Benjamin Delphi released Mimikatz, a new version of Mimikatz, which allows you to, even if you have CredGuard running, steal the passwords. And I just said previously, hey, if you run Credential Guard, you can't steal the passwords. Well, I kind of fibbed a little. The thing is, the way that Credential Guard works is it protects derived secrets. It's intended to protect your Kerberos TGTs. It's intended to protect the things that you can take off box and use to go across machines. You can do that with a password, but the issue is that there's a specific gap between when the user enters their password into the PC, into the keyboard, goes up into Windows, and then gets authenticated to Active Directory. There's a gap that we cannot control in many systems. And that's one of the reasons why we don't actually want you to use passwords. That's why we're recommending you go to passwordless. In some cases with Windows 10s, we block it outright. There's no way you can do that at all. That's one of the benefits of Windows 10s. There's no way that anyone can actually inject into that code path to get those passwords. So, does that answer your question? Yeah. Yes?
Way that you can disable USB drive use for users but still allow the TPM keys?
Oh, allow the FIDO keys? I don't know. It's an interesting question. I will give you a business card after, and we can look it up for you. All right. Any other questions? Going once? Going twice? All right. Thank you very much. I appreciate it.